All right, well, I want to welcome everyone to a tour of Bill Spohn's Modular Net Zero Home. This course is approved for GBCI, AIBD, Certified Green Professional, BPI, Non-WholeHouse, pending AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. My name is Brett Little, and I'm here with the nonprofit, the GreenHome Institute, who's excited to bring you this session. And the question we're going to be asking throughout this one is, does modular support net zero energy? How do those two concepts work well together? What challenges are there? That's what we hope to answer on this one specific project here. And before we get started, I just want to say a huge thanks to our top tier sponsor for the year, Build Equinox, with the Serve 2 smart ventilation system. This system, unlike traditional energy recovery ventilators or heat recovery ventilators, features many qualities of smarter, balanced ventilation and feedback monitoring. With a standard ERV or HRV, you get constant low air flow rate with no relation to actual indoor air quality or occupancy. So you can see in this chart here, for the first 3 days when the home is occupied, the air quality is poor. The ERV can't keep up. When the occupants leave on vacation, the ERV keeps venting and wasting energy. Since the Serve actually monitors air quality, it ventilates only when it needs to. Compared to an ERV, the Serve can ventilate up to 300 CFM, quickly purging pollutants from the home. When no ventilation is needed, the Serve can recirculate and unify the home, providing some additional heating and cooling and dehumidification in an energy efficient manner. The Serve does this by monitoring all, CO2, volatile organic compounds, as well in the air, and then exhausts as those levels reach their thresholds that their clients set that they don't want them to be at. Now, instead of an ERV exchanger core, the Serve uses a high efficiency heat pump to exchange energy between the incoming supply and outgoing air, which means conditioned, comfortable air unifies the home instead of dragging exterior rooms away from that comfort. The Serve access panel allows the homeowners to easily access and inspect the filters, change them, and they get up to MERV 13 and even 16 now, which is very important for reducing viral transmission. Really cool. The Serve is manufactured right in Urbana, Illinois, in a facility that's 100% solar powered. Very cool. Hope to see that from all businesses. The Serve can work well with a heat pump water heater, such as the Rheem Prestige, to boost its capacity, or work with Radiant. Can work really well with our friends over at Mitsubishi to distribute mini split air more efficiently around a home, and works with our friends over at Water Furnace to do the Geo Boost to improve geothermal energy distribution. So make sure to go check the Serve 2 out over at buildequinox.com today. Also, a huge thanks to our second tier sponsor, T-Stud. We're talking about structurally insulated framing systems that are built nearly the same way, that keep thermal bridging reduced. They come pre-insulated like on the left there, or they come completely bare naked where you can add your own insulation if you don't want to use foam. Very cool product. Check it out over at tstud.com. So with that, I'm super excited to introduce Bill here, who's the owner of True Tech Tools Ltd. He's an entrepreneur who is willing to listen, learn, and cooperate with an eye towards bettering the world in any small way he can. You can check out more about what's on his mind, download or subscribe to his podcast. And so with that, Bill, I'm going to hand it over to you, and please do take it away. Oh, you're muted. 1 second. That's my fault. Give me 1 second here. There you go.
Because I'll do a lot of it. And I'm really thrilled to be here, and thanks for the invitation. And I just love talking about this project because it's occupied so much of my time for the last 2 years. We're standing outside right now. I'm gonna ask my son, who's doing the camera right now, to give us a quick little view of the kind of the periphery and the land of what we have here. We're on a 3-acre lot. This is called Pittsburgh level. You might see some hills and some slopes, but this is what we call level land in Pittsburgh. So we have a 3-bedroom house that's been built in a factory, modular built. It's 2 stories, and we also have a detached garage that connected via a breezeway, which is also kind of a aesthetic feature as well as just a functional feature to keep the garage separate from the house. So I think we want to kind of just take a look up and down at the outside here, the front, and then we'll take a little walk over to the solar panels. And maybe while we're walking there, you want to bring up that slide, Brett?
Yep.
Okay. So the slide discusses the size of the solar panels, the output, and even in here's quote unquote sunny Pittsburgh, which a lot of people think is a very cloudy or rainy city. Or anyway, we do get sun. We get sun every day. As little as 1 kilowatt hour on some cloudy days recently. And but on the summertime, since we've had the system connected, we've had up to 80 kilowatt hours produced during the course of the day. Okay, so we're taking a walk over to the panels now, and we can just take kind of a view. And there's 32 panels here. We were able to kind of sneak in and get an upgrade to the 375 watt panels. We took part in National Solar Co-op, which had a local segment to it, which allowed us to get a very good price on this system. We'll take another walk around here and just quickly show you, because it's cold. Quickly show you here, there's 2 inverters and converting to AC outside here, and then we feed it back into a net meter. We're very lucky. Pennsylvania has net metering at the price I would normally pay. So we have built up a bank of kilowatt hour credits. Let's head back over to the house and walk around here. So the
Bill, a little bit about the production.
Sure. So the production, we've only lived here less than 3 weeks. Just before Thanksgiving, we got in. So we're still trying to figure out like kind of our energy use and our energy budget. And the production's been, we've been throughout the summer when it was under construction, we were connected, and there was a lot of days where it was banking and coming through the net meter. Lately, though, we've been consuming more because it's been colder and cloudier. Just a quick look here at the interconnection for the solar panels. And it's kind of cool. You can actually see the meter says net when it is producing outside, but it's probably not doing that right now. Now we'll spend a little bit more time outside here, just another quick walk around and show you the outdoor unit from the air source heat pump, as well as the inlet and exhaust from the ERV system. You can see this is the exhaust because it's blowing right here, and the inlet is next to it over there.
So that little device there is your entire heating and cooling all in one, right?
Yeah, absolutely. Yeah, it is. It's designed to be 2 tons, which was the model through both the passive house planning package and a Model J calculation done by a seasoned contractor, not by me. So I can blame him, not me. But no, it's working well so far. We've had to get used to the fact that the heat pump brings in very mildly tempered air, so you can't have really wide swings in the load or any big setbacks or anything like that. So we're learning about all those things. I did take some thermal pictures last night. I don't have them in the slide deck, but I was just looking at the different walls and surfaces, like in the ceiling, the vaulted ceiling, and other areas, and only seeing like 2 to 3 degrees Fahrenheit difference between high and low walls, that kind of thing, which is what we designed to make this an energy efficient home to take care of the expensive air that we're creating. We used passive house, triple pane, argon filled windows everywhere, including this patio door, which is actually kind of unique. It's actually a passive house patio door. It does swing back and push in like a plug to seal and to close. So I think we're going to head back inside now. Oh, wait, one more thing. We are doing some rainwater harvesting. We actually had to put a well in on this site as well as septic. And so we are doing rainwater harvesting for, you know, outdoor washing, a future garden, that kind of thing.
Bill, did you consider, you know, trying to do rainwater catchment for like toilets or potable use at all?
No, because we're working with a factory, and that's kind of interesting. I mean, they were very accommodating of requests, but not everything, because certain things sort of take them, I would say, beyond their comfort zone into the danger zone. So something like that, you know, really specialty things that maybe site built, or if I was a builder myself building it, that I would do or could do, they weren't interested in doing it, and we didn't want to lose the ability of the factory build all the benefits of it by pushing them a little bit too far. So we didn't consider that, although I think those are great ideas, but it didn't fit in with our scheme. I'm gonna head inside now.
So there was a question, how far away from the house are the PV panels?
I think I measured that once at about 150 feet. So some of what our goal was here was to include certain aesthetic components. Like we weren't going to go, I'm sorry to say, like totally efficient for just the sake of being efficient, but we wanted to have a nice place to live, an aesthetic place to live. So some people may call me out. I'll send you my email address if you want to do that.
When you say aesthetic, because my next question was going to be, what was the trade-off of putting the panels on your house versus putting them further out? Because I know there's trenching costs, there's efficiency loss, but I also know solar panel. I love solar, but I personally believe it is very ugly. So
that was it. I didn't want to pull in the driveway and look at panels the first thing, because of the perfect orientation for the front of the house would have been south facing, which would have meant we would have had to have a sloped south facing roof, and pulling in the driveway, we'd see panels. And I said, no, we're not going to do that. So we do, if you recall from the architecture we looked at before, it's sort of a, I don't know, like a modified Cape Cod, I don't know how we want to call it, but it's got some interest and detail to it that just totally negated putting panels on the roof. There were trenching costs, but we had a great excavator working with the builder who just did so much of the work all at once, because that's the way sort of modular goes. It does, you know, things are done in segments. And we are converting to AC out there with the inverters, so we aren't getting DC loss coming in. But then if we were to use batteries, they'd probably go inside, which means we have to reconvert it to DC to put battery storage inside, which we don't currently have battery storage.
what do you do? You know, do you, because from a battery standpoint, did you look at the trade-offs of adding some batteries and less solar, or consider potential grid outages at all?
Thought about grid outages, checked with the neighbors before we moved in, found it wasn't that big of an issue. Also felt like we were building such a, not a super insulated, but a very well insulated house, that we could probably, you know, withstand maybe one winter night without any heat at all. If everything was, you know, at temperature, if we did lose power, and we do have, you know, relatives nearby. Yeah, we didn't, batteries, I think, just kind of like pushed us above the budget that we would do to include all the features that we really wanted to have.
Got it, thanks.
Mm-hmm. So we'd like to take a look at some of those other slides of construction maybe at this point.
Yeah, why don't we take obviously a lot of the construction happened off-site, so it'd be great to see into the plant a little bit and show us kind of what was going on.
Sure. Okay. So I'm going to grab my laptop over here, and you're going to switch me over as presenter. Work with a local modular factory and a local builder who builds mainly modular. They've been in business 30 years, but our house did have to take its first and hopefully its last journey about 77 miles from the factory site to our home. That's one of the modules there. They number each one of them. So
or the 1,942nd module that has left that particular factory, and that's some of the work crew. I wanted to get a picture of them because they put so much good detailed effort into what's been built here. Slide, or just tab, whatever. Yeah, so if you go back, yeah, so this is just a few quick shots giving you an idea of sort of the length of these modules, 64 feet long by about 14 feet wide. They were all built with what I call braces on the outside. I'll share my webcam too. So these braces on the outside allowed it to be constructed and transported. They're 64-foot long LVL beams, if I recall correctly. But you can also see some of the framing aspects here, which the house, according to the builder, the modular builder, that they have to withstand like about a 7 on the Richter scale in terms of being able to withstand transport and being delivered to site. Press tab or next. So this is a very beginning of, I believe it's module number 1. And where they actually build them with jigs and fixtures and laser alignment and just checking everything out, every single detail out. And it was really amazing when the modules came together. And I'll show you. You can see my kind of webcam here. This is the marriage wall, the so-called marriage wall right here. So there's one module on this side and another module on this side on both floors. So a total of 4 boxes were stacked on top of each other. And this marriage wall goes all the way down the hall there. What was really pretty interesting, if you go back to the slides, the way they had to build, thank you, the way they had to build this vaulted area inside. Next slide. So this is a view of the vaulted area. Part of the construction of it, you're seeing one of the edges of it, but there are a lot of complicated geometries here. They did use CAD for everything. Any kind of sketches that we kind of wanted to insert in there to get to check if they would do these details, they had to come over as CAD files. They really stuck to a process. I also wanted to point out that in the factory, they can work on all 6 sides of each module simultaneously, so multiple work crews can be working on it. It's all in a conditioned space, as you can see in the photo. There's also a safety chain to make sure that workers or visitors like me don't fall off from the upper deck area there. Next. So we really appreciate the fact there's a consistent workforce with the work coming to the workers, not the workers coming to the work. The constant QA, met some of the floor supervisors there when we got to visit as the house is being built. The materials are always protected. That was like a real big sell point for us back in June of 18. We decided to go modular. Was taking a factory tour and seeing the fact that material wouldn't be sitting outside collecting whatever, moisture, dirt, microbes in the air, whatever, but being protected as it moves from the material factory to the modular factory. And I think, I'm not sure of this because it's really hard to monitor, but I believe since the modules are pretty open as the materials are coming together, there's outgassing happening in the factory before it's delivered and assembled as a house. So that's not a fact, but I would say that's a sort of a concept that I have. The walls are built from the inside out. We're going to look at a wall cross section here as the process of the walls are being built to give you a better idea of that. That allows for better air sealing, as you can see in that little inset photograph there of those two boxes where they are able to put the walls up on the framing and then foam them from the backside. Again, the house is overbuilt, and there's actually quite a bit of construction, I would say, more than you might imagine, that happens outside of the factory, finishing details, joining details, although things like kitchen cabinets, like I'll show you right here real quick, the kitchen cabinets are actually installed in the factory. Countertops were not. I'll show you quick here if you can see in my camera. So the kitchen cabinets were installed in the factory, not the drawer handles, of course, but all the cabinets were. Some of the flooring was installed when it wasn't near a marriage wall or in an area which was going to have some heavy work done and afterwards. So there's a lot of work that gets done, but not everything is done in the factory. We go back to the slides. Next slide. So this is, I'm going to step you through the process here photographically of how the walls are construction. Again, we're going back to the same picture with wall board on the framing. There's 2x6, 16-inch on center studs. Next. Unbacked fiberglass is then laid in. That was our material of choice. We did ask if the factory could do foam. The factory could not do foam, or did not want to do foam. It really doesn't fit in their process there. Then the next slide. Then we used a quote unquote weatherized sheathing material that was taped as the manufacturer recommends and rolled. The seams were rolled. I just lost the slide. Okay, there's seams were rolled, and then the fastener heads, we actually took the extra step, and we actually had a special line item in our budget called energy features with the factory. We had them put a putty or a sealant on each of the heads of the fasteners to help prevent perhaps any water migration as well as any air leakage that might be induced there, because we were looking for a very highly sealed home. Next. On top of that is a 1.5-inch graphite impregnated extruded polystyrene, if I'm getting that right, foam that was added as a thermal break all the way around the house. Next. And these are pictures from the factory, by the way. You can kind of see shop vacs and tools and all kinds of things around. Next, a weather-resistant barrier was also put on in the factory. Down there in the, kind of the lower corner, the lower right-hand corner, you can see rollers. These modules are actually rolled through the factory, just like sort of like a train car, rolled right through the factory on a literal production line. So they have multiple modules in process at once. Next slide. Or next, yeah. And this shows you the weather-resistant barrier was taped in the factory. I didn't get a shot of it until the house was assembled on site, but you can also see where they went back and did add more WRB and more taping to make sure that that it did function well as a weather-resistant barrier. What's kind of interesting is the builder here used a picture like this of our house in their newsletter, and then a picture of another random house that they took where the materials, the weather-resistant barrier, whatever the poly that's put on there, was flapping around in the breeze. And they said, would you like your house like this, or would your house like that? So they try to, underscore sort of pride in their workmanship here. Next slide. And then we actually had vinyl siding put on. It's a little bit thicker grade siding, so a little bit more stable. And we also used 25-foot lengths for as many areas as we could, so that it would have the appearance of being seamless. To give it just a little bit more of a high quality look to it. And then the overall wall construction comes out at R30 if you stack up all those factors that are in there. Next slide. This is the product. I find it very interesting. It's a graphite impregnated EPS. This material actually has better resistive value the lower the temperature is. It's just something that really caught my eye, became very interesting. So that 1.5 inches functions like a very high or higher resistance as the temperature goes down outside. Next slide.
Where is that installed?
That's the thermal break, the EPS that's put on the foam, the wrap that's put around the house.
Oh, beneath that. Okay.
Yeah, so it's beneath the WRB, but on top of the sheathing.
That's what I thought. I just wanted to make sure.
Yeah, sure. Next slide. These are precast foundation walls, and we're going to take a walk down. Yeah, we're going to do it. I just want to kind of go over the details here, and then we're going to take you down and take a look at that, take a look at the mechanicals, and a little bit more of the tour here for the house. Is that okay?
Yeah, let's go.
Okay, so this is actually photographs the day that the day, only in one day, well as daylight, they put in the whole foundation. These are precast concrete panels, 6,000 PSI, So they're at the level where the I guess the Concrete Institute says you do not need to put any kind of water sealant on the outside of these because of the way that they're cast. They're also filled with EPS foam that's laid inside the casting material, which provides for approximately R30 for the foundation walls. And the people that make them in the factory come and install them on site, and it's a local factory that does this. They're really great people. You can see it also goes down on crushed limestone with a dual drain system. So there's French drains on either side of the footer, so that these are really put in to last a very, very long time. Also, we're going to switch to the other camera. Okay, there we go. All right, I'll keep this going here. So we're going down into the basement. And it's a large basement. It's about 1,600 square feet. Do you have that light ready? So we're going to take you around. We did have the builder put in wallboard to sort of semi-finish it to get it started. We're going to walk you over here, though, where they didn't put wallboard in underneath the stairs and show you what that foundation system looks like. I'm going to crawl under here. Hopefully you can still see things, still see me. There you go. So this is the foam that's laid in here. There's steel strips, as you can see in that illustration I showed a moment ago, for sort of structural rigidity. They also allow channels in here, so you can put in, you can do wire runs. But behind this, and you can't see the concrete edge except maybe at the very top of the precast foundation. So also the other thing is, if you look down a little bit here, the concrete is laid up against the insulation. So there's your edge break, your thermal edge break, because this concrete is not laying against soil, it's laying against this R30 assembly. How do you like my pointer? Okay, we're gonna sweep on over here, and I'm gonna do an amazing thing and walk through a wall because we're not finished yet. You didn't catch that on video, though. You didn't catch the video. Okay. So this is framed out for some like a future bathroom, full bath, as well as office or bedroom. But we'll come on here in the mechanical room and take a look at some things, and we'll go over the more technical details, mechanical. But we'll just give you a perspective on these. This is the HAC system. It's not the V system. The V is separate, separately ducted. So this is a 4-zone air source heat pump. It has also has a 10 kilowatt electrical strip heating in it, in case we need that for if it goes, it goes beyond design days, if you will. The coil, the zones are up here, 4 different zones. Those are the zone controllers. We were particularly asked the vendor, or excuse me, the installer to be particularly fastidious about the way that they taped and sealed joints. We really have not measured duct leakage on them yet. We anticipate it will be low. We will be getting around to measuring it. This is the coil, the heating and cooling coil. It's mounted pre-blower, so on the return side. And the reason for that is the heat strips are mounted up here, and they can operate then in conjunction. So if the air source doesn't have enough, then the heat strips can be added in to supplement that, so you can get both the 24,000 kBTUs out of this, as well as 10 kilowatts here, which I think is close to like 3 tons of heating, the equivalent like around 3,400 something of heating. We have a MERV 11 filter, 4-inch pleated filter. We went with some people are calling big drops, and we wanted to have a very uninterrupted airflow coming back through the return system, so very generous returns coming back. There are 3 returns, one coming from the basement back here, one coming from the upstairs, and one coming from the first floor. So that there are now separate returns in rooms. There's such a low flow. At 2 tons, we're talking somewhere around 800, 900 CFM perhaps, that there isn't a lot of flow that you need to bring back. But we did go with the transition box here to sort of restabilize the airflow and then bring it over a 4-inch filter. Kind of sweeping around here, there's a heat pump water heater. I think people are probably pretty familiar with those. We do have a water softener system as well as a on-site well. This is the the holding tank and the pressure tank. And this is the ERV, the conditioning ERV, which you did mention some details about before. It is that brand of the sponsor. So this is, I can show you over here. That's a real-time view of the conditions right now with the sensors. It's a little bit hard to see. Maybe back up a little bit. Yeah. Okay. So it's giving you the conditions of temperature, humidity, CO2, and VOCs. And we're doing our set point control off of CO2 level. Also a radon monitor, which we need. That looks like we do need. We did have installed a passive radon system, sort of like radon resistant construction. That's this tube here that goes straight up and out the back, a 3-inch. It's sub slab open to like a gravel pit area. Unfortunately, though, there is higher than good radon levels present. So we're going to have to go up and inside a little attic area that we have, a knee wall area, we're going to have to add a fan to do some powered radon exhaust.
Do you know what zone you are in there?
Pennsylvania. Western Pennsylvania, undermined. In fact, they had to buy mine subsidence insurance. I mean, it was smart to buy mine subsidence insurance. And sort of anecdotally, in the process of drilling our wells, we had to drill 3 of them in order to get one that worked. 2 of them had trouble holding water, we believe, because the mine came into contact with, the well came into contact with the roof, mining timber roof, that then caused it to leak through and to not be able to hold in a little pocket reservoir. So we had to have a 3rd well drilled that was a little bit more cautiously drilled. But this whole area that we're in right here, if you look on the map, is just all undermined. And I believe that's part of the radon issue, that a reason why we have some radon issues here. So want to go back to the maybe the mechanical slide, and you give me presenter control.
Yeah, let's pull it up.
Yep.
And real quick, I don't know if you were going to mention more on the heat pump water heaters, but I do know actually surprisingly a lot of folks still are learning about those. So I don't know if you had any. Just quickly like cover what it is and how it works.
Sure. Do you want to switch the camera back on, please? Okay, there you go. So there's actually a heat pump up here. There's the 2 coils on it. When it's operational, it is pulling in air from the basement up and this grid right here, this grill here. There's a little air filter of sorts to catch crap before it gets to the coil. And then it will blow out cooler dehumidified air essentially from this panel here. These are set up, this design by this manufacturer set up such that it could be ducted. You could bring in outside air if you wish, and you could reduct this into a room if you wish, because it is cooler air than what's going in, because it is extracting the heat going through the system. So even though the basement might be at like 66 degrees Fahrenheit, it's still going to bring water temperature up through the magic of heat pumps up to 132 degrees and hold it there. So this whole upper unit here on the top head is just basically, it's a heat pump with 2 coils in it and a fan in it. The rest of it is a storage tank. It does have electrical resistance heating in it, and you can pick different modes. I don't want to put it in vacation mode, but it's on Wi-Fi. It can be set up with different sensors in it. I'll wait for it to go back to the home screen. I deal with this mostly on the Wi-Fi. on the app. But it's you can set it up to different modes. You can set it to high demand mode, where we'll use both the electrical resistance, which is not as frugal electrically for efficiency wise, and the heat pump, or you can set up electrical resistance only, say your heat pump goes down. Although these are this is the 4th generation of this type of product from this manufacturer. I have a lot of confidence, did a lot of research. A lot of people are going this way, this direction. And when you run it in heat pump only mode, what's that? When you run it in heat pump only mode, I don't want it on vacation. I'm gonna have to go fix this, or somebody's gonna yell at me. Heat pump only mode is the most efficient mode, especially like us. There's just 2 of us living here. There isn't a real high demand, just at a couple of points during the day, so it can do very well. I don't have installed yet, but I have very dangerously exposed my electrical panel box. I do have electrical sub-circuit monitor with, I think it's 16 CTs, current transducers, ready to go, ready to install when I get around to it, if I stop doing webinars.
All right, there you go. I got you on a screen share now. So.
Okay, so I'll turn on my webcam. Okay, so we have here talked about the efficiency and comfort aspects, the HVAC system, and wanted to point out it's separately ducted systems. Heating and cooling is the air source heat pump, and then the V system, ventilation system, has all of its own ducts. Those ducts are the supplies, or the returns, if you will, from the ventilation system, or in the laundry room. A closet, which I guess I probably should show you because it's kind of unique. It's not a conditioned space, but it's inside the thermal and the vapor envelope. I'll continue to walk upstairs here. You want to put slide? Yeah, thank you. So the ventilation has the supplies are in the living room, the office, and all the bedrooms. So all the places you're going to spend most of your time should have the bestest, freshest air. I'll show you up here, if you can see my screen on the wall. There are 4 little nozzle vents there.
Yep.
These three are for heating and cooling. This one is a ventilation vent. So this is the one that comes in to bring in the fresh air to this space. In the other rooms, the ventilation vents sort of look like classic returns. Like this is my office. That's the ventilation vent. So that's bringing in fresh air when that ERV is running. And then the heating and cooling supplies are here. So each one of these supplies about 30 CFM. Each one of those nozzle vents supplies about 30 CFM. I'm just pointing upwards here. There's all LED lighting through the whole house too. You can see my solar shade. We really just moved in. That's actually a duct mask in order to keep the glare off my eyes when it gets really sunny. Swing around one more time. Give me the camera back again. And show you the just the camera on my laptop. Yeah. So those are this is the return for the first floor. We sort of insisted on they were going to give us a little bit less return volume, but we insisted on this, so that's why it looks sort of odd. It looks like there's 3 little ducks, 3 little pigs running there. All right. Let me back the slides.
There you go.
Okay. Okay, next slide. So that's a picture of the system that we just looked at. If you hit the slide again, shows some kind of spell through the details. If you hit, there you go. So 2-ton ducted air source heat pump, 21 SEER, 21.5 SEER, 4 zones. The 4-inch horizontally mounted MERV 11 filter, I didn't mention there are the MERV 13 filters in the conditioning ERV, both for the inlet and the outlet air, and about 0.8 of an inch water column air handler, a little bit higher than typical, and that's largely because of those that duct system with the medium velocity ducts. Next slide. That's just a picture of the coil inside there while it was being installed. It is mounted horizontally. There's some special shielding in there for water drippage and spraying back and things like that, but it works really well. Next slide. So these are the heating and air conditioning ducts, and they use this nozzle duct system that they've done computer modeling of. That's the picture in the lower right-hand corner there, which shows when you're just kind of coming up from the floor and sort of mixing around the room. The idea with these is they sort of spray off across the room. They don't, put the velocity on people, but they do sort of go towards the rear of the room and then mix and then condition the whole space in a little bit more uniform method. So our old house built in 1980, it was always sort of annoying for me having a very large heat exchanger at the top of my head. When the air conditioning or heating would come on, just the velocity of that coming on, with a 4-ton system blowing a lot of air around. So we find this much more comfortable. Next slide. That's the conditioning ERV. Press again. Some of the details, I think I covered most of that. I call it pretty smart because it turns off when it's not needed. Brett mentioned that a little bit earlier in terms of how ventilation sometimes runs when it doesn't need to run. This only runs when it needs to run based on the parameters that I set. We did add a UV bulb upgrade. They have a very interesting design where they have so much reflectivity in this chamber that they do get 85% DNA deactivation for any kind of particles or viruses that are in the air because of the nature of the system, low flow and high reflectivity for the UV bouncing around in there. And again, I said we're using a CO2 set point of 800 ppm, and that's sort of from the good advice from people out there doing research in terms of viral control, things like that. Next slide. That's the the data. There's a portal and an app for it. Some very interesting pollutant exposure information, which I really like. It combines both the VOC versus the CO2 on the same chart and gives you the kind of circular graph in the lower right-hand corner. It tells you about your exposure, and then actually has like a community exposure level, which is really interesting, of all the people using this particular branded product. Next slide. This is data running only up till October 15th, so this is a full month before we moved in. Press again. There you go. So I was doing a lot of painting in here, and you can see the VOC levels are like spiking off the charts, and that was largely due, I believe, to painting. The green line there in this data tells you when the system is running, when the ERV is running. The white area is when there's nothing running, and the VOC level is plotted in the orange line, the CO2 level in the pink line. That's okay. Next slide. Also, it's interesting that, again, this is a house unoccupied, so we kind of let things drift around where they might, but it can tell you data about both the incoming airstream into the ERV as well as the conditioned airstream of the house that it's pulling back through in the return sides. And again, I'm sort of still learning the controls. I was probably over ventilating our first week or so here. And I'm going to be back in touch with the manufacturer to make sure I'm doing things correctly. Next slide. And this is the humidity control. Yeah, anyway, that was humidity control. There were times there when we had the windows and doors open because we were here cleaning or doing whatever or moving or something was going on construction. But it's always just interesting for me to see the data now. You hear about these things, but then when you actually kind of living inside your theories, that's another presentation I'm going to do in January, living inside my theories. Next slide. We have Wi-Fi thermostats for the 4 zones, so we can look at runtime. At this point, those little kind of dusty pink areas are showing when the Wi-Fi, or excuse me, the zones were running on recirculation only. And this, I turned them off, recirculation, because why do I need to recirculate when the serve's doing excess? So I sort of thought I had systems fighting each other, and really was sort of working that out. Next slide. We saw that from the outside there, the ERV, exhaust, and supply. I guess I labeled them backwards because there was air blowing out of the one on the right. So I'm going to have to change this slide. Next slide. We have Energy Star appliances here, wherever you can, fridge and dishwasher, induction range, again, trying to go with small of a electrical footprint as we can. Next slide. Oh, that's just to show this is that whole control. Yeah, that's the exhaust for the microwave range exhaust hood that leads directly outside, just 6 inches through the wall, and the exhaust, so it's a straight shot outside. This is the taping over we did to do the blower door test, but that's sort of the only known uncontrolled hole that we have in the house is that one. And sort of a compromise we had to make because of just the way everything was kind of stacking together in the kitchen, everything. This is right behind me here. That microwave, the exhaust for it is ducted outside, but it goes straight out the wall onto that breezeway area that we looked at.
Bill, was there any consideration to use the ERV for your hood vent instead?
It was not recommended. However, if you bring back the camera again, I'll take it down. That is an ERV return in the kitchen. Again, we sort of had to get creative with as much space as we could. So this is right by the range and right beneath the microwave. So that is pulling in return air from the ERV in the kitchen area. So that's one of the returns. There's the other returns of the bathrooms, laundry room, and that closet area that I mentioned. So that's, after a while, I'd say, especially in modular, you get to the point where you go like, well, where do you want to put it? What are you going to give up here to move this over there? So, and things also have to sort of move to a schedule, and because they are working in a factory. Go ahead.
Right. And I know, from a cooking standpoint, besides a little bit of humidity, PM 2.5, right, is kind of your risk there. Is that something you're measuring at all, or does the device measure that at all, the ERV?
The ERV doesn't, because they haven't found a particle sensor they like. I've talked to the people there. I do have particle sensors here from other products that TrueTech sells and plays with. They aren't set up yet, but they will be. So we'll have some data on sort of the overall IQ picture and be doing some comparisons between. So I'm not looking at it yet, but I will be looking at PM. And also this is an all electric house, so there's no gas for any kind of particulates coming off like a gas range or water heater or anything like that. High efficiency clothes washer and dryer, no venting. So that was another sort of uncontrolled hole to get control over. So it's a heat pump clothes dryer. And it does have longer run times. You got to kind of get used to how they work. But the no venting on the dryer was chosen to control the house pressures and the air leakage, not to sort of fight that. The only one that we're going to have to deal with is the microwave over here.
Do you get that that heat kind of smell off the dryer, or did you notice that the first few runs at all?
No, I'd say the only thing I notice is because it's in its own separate room, right over here, the laundry room. So the only thing I notice about it is it's a little bit warmer in there after it's run through a cycle.
Right.
Next slide. Okay, that's one of the models done of the house. It's fairly accurate. And just sort of the details and descriptions of the different features that we built into it, and starting to live within these theories. I think there's one more slide, but it's sort of like a closing slide. Yeah. So that's actually a rendering of the house, because the landscaping looks nowhere near that nice at this point. And I am doing a blog that I post more of the private Facebook page, but I got to move some of that over to the blog because I know not everybody is on Facebook. But spohnhome.com, where I talk about sort of the goals, ambitions, how things are running to keep people informed on it, people that are interested.
Great. Well,
and Brett, if people were really here, they would get some brownies. But they're not here. I mean, this is a virtual tour, but can you smell these guys?
Yeah.
Some coffee, brownies. Okay.
Good lunch. Right. So my mouth is watering. Well, great, Bill. Thanks for having us out. And we got a lot of questions coming in. I have some questions. Can we stick around?
Sure.
Do some more questions, hang out with you? You can eat a brownie and make us all jealous.
Nah, I won't, because then I'll be munching and sloshing things around.
Yeah, well, real quick, before we get to this, I just want to remind everybody who wants to pick up their continuing education units, please, when we close out, take that survey that pops up. If you miss the survey, it'll get emailed to you with your CEU details. So check your spam for that if you don't see it. For those of you watching this in the future on demand, make sure to take the quiz with an 80% passing rate. And you can find that quiz on our YouTube channel, at least, clicking on the YouTube link, heading down on the left there, clicking Show More, and over on the right, seeing where it says Need CEUs, and then you can access the quiz and go from there. And as those questions are coming in, just real quick, a huge thanks to our top tier sponsors, Mitsubishi Electric, Rheem, and Build Equinox, as well as all of our volunteers, our members, and our board of directors, everyone who allows us to do what we do. Big thanks to them. So yeah, let's dive headfirst into some of these questions here. Maybe let's go back to the factory real quick and see, there's several questions there. You were talking about length of, I think, the house or parts. What is sort of the maximum length? What do you see there in the modular world? Is it different per plant?
I think it's different per plant, but also it depends upon the logistics of delivery. They had to resculpt the driveway here and the road that we live on. They had only one direction of access on it, but so they pretty much before they commit to a house design, the factory sends their driver out. And it's like, can you deliver? What can you deliver here? And the guy really is amazing in the fact that he could bring a 14 by 64 foot module with probably another 40 foot of trailer, tractor trailer in front of it onto this site.
Talk about, did you consider stick build at all? What were some of the trade-offs, cost benefit analysis, kind of at the top high level?
Sure. I think when we were looking at stick built, there was a builder that friend of mine, someone who's been on the show, Nate Adams, a friend of his, a builder in Cleveland, who, if he would have come our direction 120 miles, we probably would have used him and probably would have stick built because I understood that he understood factors that were important to us. We did go to a home show. When we mentioned the words passive house, we got funny looks from a lot of the builders. Seriously, they didn't know what a passive house was. Then when we started, because we're heading in the direction of passive house, then we looked up online passive house builders in Pittsburgh and came up with 4 or 5. One of them was this modular builder we ended up with. The other ones were not. They were doing commercial projects or multifamily, that kind of thing. or were educators or hadn't yet executed a project. So we were leaning towards passive house, and we went with, we might have ended up with a build. We actually had a passive house architect who worked with us for a period of time at the beginning. He had recently completed a passive house the year before. He ended up having to dismiss his first builder and hire a second one, and then guide him by the hand through every step. But he was an architect. I'm not an architect. I couldn't do that. So we had to go with this sort of hybrid solution. And for us, the modular builder fell in our laps.
Speaking of passive house, so you use some of their, modeling applications. How close did you get? What were some of the barriers? Did you kind of go back and see, based on the construction build, how close you were? Yeah.
So I think the only thing that we don't have perhaps is the air changes per hour. We're ending up closer to 1.1 right now. We did do some fixes after that last test. We might be a little bit lower. Our goal was 1 because, and also the other thing was insulation. Passive house would require much thicker insulation. And if we went to thicker insulation than that 1.5 inches that we put around, if we went to thicker insulation, then we'd have to build up a rain screen in order to put cladding on. And then we felt like the extra insulation plus the rain screen, that started to stack up and take us budgetarily out of the mix for other features that we wanted to have.
Speaking of insulation, do you have below slab insulation, or was that maybe one of the concerns?
No, we went with 2 inches below slab. We didn't go. I know the architect that we were working with before, I think he had literally 14 inches of sub-slab, because he was built on grade, but with a basement where it's a little bit warmer, we went with 2 inches or 4 inches. I think it's 2 inches. I'll say 2 inches, but it might be 4.
Just be safe.
Yeah. It's 2. That's 2 because I remember seeing it here. Yeah.
Yeah. So on the well, you were talking about on the modular side having to sort of push them a little bit along to get to this level, sometimes backing off where you didn't want to do that. What were some of the areas where they had to build a little bit different or maybe better than what they usually did? And do you think that those changes are something that they're going to embed in their plant, or was this like a one-off thing?
I think I actually asked some of the workers when we toured the plant as they're building our modules. They were putting some tapes around the windows. And I said, so what do you think of this stuff? I've never used it before, but it's pretty cool. We'll probably use it again. That was like, that gave me this is from a floor worker, a laborer saying that, gave me the concept that it's being embraced. We brought to the builder a local passive house window vendor who does mostly commercial work. But we sort of discovered them at a passive house conference, and they're like 60 miles away from the build site. And they were actually being used now by the builder, being used by the factory, as well as this ERV too got used in a couple projects. So I think we did do some introduction. Some of the challenges, you might recall from some of the outside pictures, the roof lines. I remember the supervisor on the factory floor saying to me, Mr. Spohn, do you realize you have 9 roof lines? And he got real close, 9 roof lines. You're not making it easy for us here, dude. But their salesman signed off, their engineers signed off on it. And I actually have some really neat pictures of that supervisor coaching one of the workers, applying the roofing shingles to make sure that they continue to get, continuous drainage and good sealing, that kind of thing. So I think we stretched them, but we had an impact, and they did a really nice job for us.
Was the was the ducting, the HVAC systems, the water heater ventilation, was that easy for them to incorporate, or was that a pretty, I guess, hefty ask too?
Actually, the heating and cooling system is a design that the builder uses almost exclusively.
Okay.
They like it because they usually are building small inner city structures with high efficiency or low load. So this particular manufacturer makes units as small as 15,000 kBTUs, gas and electric. So the builder was very familiar. They had worked, I don't know, maybe 5 years with the factory building other houses with this kind of ducting system, these tubes, if you will. So the factory really, that was nothing new to the factory.
Mm-hmm. Was, removing gas lines from the house, made it easier on them on the modular side, or really no change?
I don't think there's any change because I mean they're doing it all the time in the other projects they build. So I don't think that caused a positive or negative change for them.
Sure. So let's talk about some of your, choices here. There's some questions on, why you selected a ducted air source heat pump system versus a geothermal system, which we know is some of the maximum energy efficiency, can produce hot water. Or, we see a lot of newer homes now getting rid of ducts entirely and using mini splits. So, I mean, can you just briefly talk about if you considered those options and why you went the way you went?
Sure. I have a good friend up in Canada, in Vancouver, who's a ground source maniac. Actually, I had to throw him off my Facebook page for a while because he started arguing with people so much, but I've let him back in since then. There's quite an expense to it, and I think with a little bit higher load than 2 tons, like if we were in the 3 to 4 to 5 ton range, it would have made much more sense. But I believe when you get to like that lower tonnage point, there's a tipping point where geothermal doesn't make that much sense. That's the way I felt. In terms of going with mini splits with heads, I don't like the aesthetic at all. I like the way these nozzle vents kind of disappear, and also the way they mix the air versus like a head unit being placed in there. So those were my choices, or our choices.
Yeah, fair enough. I'm just trying to see. There's so many questions here. I think some folks are definitely going to have to follow up with you after this, and hopefully get some of their questions answered.
Sure.
There were. Did you? Oh yeah. So ventilation in the bathroom too. Did you utilize the ERV for that, or do you have a separate ducted system?
Nope. ERV is it. This went back to a good friend of mine here locally, who's passive house trained tradesman, as well as a HERS rater, as well as BPI, and done multifamily and single family housing. And it was just when we hired him as a third party quality assurance to look at the factory, look at the designs, look at the installation. And he was just like straight, no, you can do this. This is what you want to use. So we actually, this particular ERV has these wireless switches where you can then set up with the control module a timer. So when you tap the switch once, the fan will boost up to maximum throughout the whole house and run like a 300 CFM for 15 minutes is what our choice is. If you want it to run longer, you can. So we have switches in the bathrooms. Yeah, that's it. We could put one in the laundry room. There's another switch here hanging around.
Someone wanted to ask if you can just elaborate a little bit more on your roofing insulation.
Yeah, and I got really think of the detail here. I just shared it with somebody else who's doing another energy model of the house. There's R15 foam in the vaulted area. There's R15 foam board coming down, and then there's R30 bats going up in the vaulted area. And that's where I was doing those quick thermal images last night and seeing, wall temperatures at the floor like 67 and wall temperatures up there 65. And not a lot of, you could see the studding, but you could see the studding because it was a sensitive camera, not because it was like blasting heat out like a heat exchanger. There's areas of the attic too where there's some blown in insulation in the flat areas. because not everything is vaulted here or has dormers in it.
Were the windows installed at the wall sheathing or on top of the outer rigid insulation layer?
They were installed in the factory on top of the wall sheathing, must have been, yeah. So I remember seeing them kind of taped out and ready for installation. But they did put the foam and the weather resistant barrier and the seals back up to it. All that was done in the factory. They basically came ready to install and assemble, or ready to merge on site.
Yeah, speaking of that weather resistant barriers, someone's wondering, is that the same or similar to Tyvek in any way, or how is it different?
No, this I believe this actually breathes out, so it will allow drying potential. Yeah, so it's permeable. It's not it's resistive, not water resistant.
Mm-hmm. Is the insulation behind it permeable though?
The EPS?
Yeah.
I don't know.
Yeah.
I
don't remember if that one is or not.
Yeah, I think it's vapor permeable, but
Mm-hmm.
not water permeable. And I did post some details on another page, some LinkedIn page, or some researchers testing things like those weatherized OSB or the weatherized sheathing materials. And he was a little concerned that I had two boundary layers built in there, but this again, my consultant pulled this from the things like the Building Science Corporation, BSC. Some of their wall designs is where this came from.
Yeah, that makes sense. So Pennsylvania, if I understand right, is the national capital of modular housing. So how does that play out with code? Was there a barrier to doing this with code officials, or is it pretty much standard now?
The modules are actually inspected in the factory by a Pennsylvania state inspector. So actually, if we crawled under the sink here, you'd see a sticker for each one of the modules. So there's like 4 stickers. The plans are reviewed by the state. They do something called res check, for residential energy systems check. So there's a lot of detailed plans are reviewed. The local code official was, when he let the building permit out, he was aware of the mode of construction. He had no problem. He said, like, if somebody else is checking it and they meet these standards, I'm fine with it. We'll just, we don't have to do a tremendous amount of on-site checking. I think he came out maybe once or twice to the build site, because it really wasn't a build site, an assembly site.
Right. I know there's the solar tax credit, of course, which is dropped this year. Any other special incentives or anything that either you were able to use or that helped you do something you might not have done?
I did get some sort of sponsorships from some of the equipment manufacturers, which was nice. Some reductions in cost there. Our appliances qualified for manufacturer rebates.
Right.
I'm trying to apply for local utility rebates for energy efficient appliances, but they don't recognize this address in their system, so they kick me out.
Right.
Still working on that issue. The other thing is, what's that?
As long as they give
cover. Right. That's a whole other story there, but that actually worked out fine. The solar renewable energy credits, we didn't talk about that with solar. There might have been a slide on that, but basically that's where I have a tradable commodity for every megawatt hour that's generated. I've registered actually as a solar power plant with the state utility commission. They make it really easy, under 50 megawatt hours a year. So registered, have something called the solar renewable energy credit, which I use a platform to trade the energy credit, where utilities are mandated in various states to get so much from renewables. They can buy the fact that renewable energy is being created here. They don't buy the energy. They just buy the fact that energy is being created here. A certain amount is being put into the grid, into the system. It's largely relegated to the Northeast. I think there's maybe 8 states or so. Yeah, there you go. If you go back one slide, I think it's yeah. So those are the states. What's called a solar. What's that?
I'm not in it.
Oh, you're not in it.
Yeah.
Well, you're in a solar carve out, and where it says OH,
Right.
Your utilities could buy from the Ohio market. Indiana, Kentucky, West Virginia, Michigan, and Ohio, or excuse me, PA, utilities can all buy from the Ohio market. And then if you hit the next slide, this is what the login looks like. And this was the first one that I submitted. So I have to put in readings every month for my power production meter of how many kilowatt hours I've produced. And every one that I go over, and they hold the remainder, every one that I go over for megawatt hours can get an SREC. Hit the next slide. This is the price of a SREC, solar renewable energy credit, in the state of Ohio. It is a commodity that is traded, so it moves, its price fluctuates there. So like in September, around $10. Pennsylvania, it was around 45. The beginning of the year, dropped to around 20 now. If you get it, next slide. Washington, D.C. Boy, I'd love to have my house in Washington, D.C. $430 per SREC, and I'm producing around 14 a year. So 14 times $430 can really help you reduce, offset the cost of solar. Right now we're running around 20, so 20 times 14 isn't so lovely, but it's something.
Speaking of solar and versus energy use, what is your projections for the year, just based on what you think you're going to net out on? I know you're probably tracking it and you're going to get real data.
Yeah.
But, what I assume you had some predictions based on your design and your solar that you would, and it sounds like you get paid for it, that you would net out at the end of the year. Do you know how, what that kind of target is in kilowatt hours?
No. Actually, when the solar system was designed, it was designed with by the installer, who did a fantastic job, helped us get everything set up. They designed it sort of like with a ballpark. And I actually tried to go in and figure out what our consumption would be based upon our old house, and then new appliances and everything new at the new house and being all electric. And I got so lost in the detail and just came up with unreasonable numbers that I just abandoned it.
Okay.
So I think when you add solar to an existing home, you really know what your consumption is going to be. But we had so many variables going on, we just sort of like spun the solar roulette wheel, and we'll see which. The target is to be net zero. I think we'll come very close if we don't make it. But part of it also is kind of understanding and getting things under control. Like I was over ventilating, which means I was bringing in too much fresh air when it was 30 degrees outside, which means I had to condition that air, which I was expending extra energy, yada, yada, yada. We don't, so we got to learn how to drive this machine.
Yeah. You're going to be a little more engaged operating your house than the average homeowner, right? Just making sure you hit that target. So, and did you pursue any kind of energy labels, green certifications for this, or have any consideration of that?
No, I sort of, the different presentation I did about this, I talk about this as being a personalized performance home, and rather than a labeled home. I think labeled homes are really good when you're trying to explain this vastly complicated area, which still is exceeding my understanding to someone who's not anywhere near that level of understanding. I am pursuing a Pearl certification because I want to give them some credit and some visibility. I think they're doing a great thing for the aftermarket, sort of a non-governmental certification program. But aside from that, not having the home rated or anything like that, or any labels. Although I think if the passive house planning package is correct, this qualifies as a low energy home. or low energy consumption home, which is just like one step above passive.
Yeah, yeah, absolutely. Well, I know there is still some more questions in here, but we could probably go on with conversations all the time. So I think we're a little bit over time, but I think we're going to wrap it up from here. And then hopefully, maybe a year goes by or so and you've got some data, some lessons learned, and you've got some brownies that we've figured out how to put through the camera virtually. By that time, we'll know. We got to know.
We will.
That works on, yeah, smell. So maybe you'll invite us back out and we can do a quick walkthrough and catch up, right?
Be happy to, yeah.
Yeah, great. Well, Bill, I really appreciate your time for doing this. Thank you all for joining us here. I hope everyone has a great Christmas out there, a safe holiday, and we want to see you all in person, hopefully sometime in 2021. So, let's beat this thing. Let's, stay masked when we can. Let's use building science to help get us out of this to some degree. And I wish you all well. So take care. Thank you so much.
Thank you.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.